Hello everyone, let us now discuss today's LeetCode POTD problem. Partition equals subset sum. So we are given with array nums. Return true if you can partition the array into two subsets such that the sum of the elements in both subsets is equal, or false otherwise. So let me tell you that here we are given with an array of size something as n. Now we need to know whether we can partition this as a subset into two subsets. That means we are partitioning into two subsets such that the sum of these two should be equal. So if I take this as sum s, then the total sum will be 2s, and this 2s will be equal to total sum. Now, let me write a condition that if I have 1, 1 and 1. Now, it is impossible to take a partition from this, because if I take this as a partition and this as another partition, it is having a sum of 2, it is having a sum of 1. So, what I need is an even total sum. So total sum should be even. If it is not or even, then we need to return false. So the first observation is if if the total sum is not even, then return false. Now I have something like s, which is 2s by 2, something like total sum by 2. So total sum by 2. Now if I find out this subset, then there is no need to find out the second subset. Why? Because if I am having the sum of this subset as s, exactly the sum of the other subset will be s. The total sum by 2 is equal to s. So if I found s as any subset, then I'll return true. Now, if there is any subset with sum is equal to s or total sum by 2, then I'll return true there itself. Now, let us see how the intuition goes like. So, I need to get whether I have a subset of sum equal to total sum by 2, right? So I can use a recursion. That means I will go through all the subsets and get whether can I get a total sum by 2. That means here the half sum. So I can use recursion. So if I go to the recursion code, first thing which comes into my mind is I am not taking anything. The subset is empty. If I write 0 index, but before that let me write 1, 5, 11 and 5. The total sum here is 22, and the target sum, that means total sum by 2, is 11. So in the subset that I am taking, that should not exceed 11. It should be lesser than or equal to 11, but should not exceed 11. Now I have 0, I have 1, 2 and then 3. These are the indices of the array. Now if I take the 0th element, then the subset will be looking like 1 and the sum is 1. Now do I really have to get or to store this subset in an array or something like that? No, I can simply take 1 as the current sum and 0 if I don't take element at index 0. Now I am taking 5. 5 should I take? Yes, because if I add 5 to 1, it only makes 6, which is lesser than 11. So 6, and here it is 1. Now, can I take 5? Yes. If I add 5 to 0, it only makes 5 and it is lesser than 11. Now, can I take 11? 11 plus 6 will make 17. So, I don't take this. Now, that means here there will be no recursion from this step. Now, if I don't take 11, it would be 6 itself. Now, if I take 11, it will be 12 and will be stopping here itself. Now if I am not taking anything, it would be 1. If I take 11, it would be 16. If I am not taking anything, then it would be 5. If I take 11, then the sum will be 11, and if I not take 11, it would be 0. Now I have 5, the last element. Now can I go here? No, I can go from 6 to 5. 6 plus 5 is something like 11, and if I don't take index 3 element, it is 6. Now I cannot go here, so I stop this. That's it. Now if I take 5, it would be 6. If I don't take, it would be 1. Now this I cannot do because it exceeded the limit of 11, that means the target, so we don't do a recursion here. So if I take 5 plus 5 will give me 10. Now if I don't take it, 5 itself. Now if I take 5, it would be 16, and here it will be stopped. However, it goes out of bounds. Now we are going 11, and here 5, and here it is 0. If I take 5, it is 5. If I don't take anything, it is 0. Now what is the intuition here? If it is equal to 11 at this point, I will return true, but here it is returning false. So at this point here it should go and check whether the taking will give me true, or else not taking will give me true. Either any of them will give me a true, then I will return true at the last. So here I will get true. Then here I am getting a false because it is going out of target. So either of these two, if returning true, then it will be true. Now here it will be returning, all this will be returning false, all this will be returning false, but here it will return a true, here it will return a true, here a true, and a true here, and also here a true. So any of the two is returning a true, then I'll return true at the last. What I am checking every time, I am checking take, not take. So when will I take? I'll take, let me write first not take, and then I'll write for taking. So when will when I am not taking, then I'll be calling for a recursion of index plus 1, and the sum will be same and the nums. Now if I am not taking this, it is, and if I am taking, that means if I have to take, so sum plus nums of the current index should be lesser than the target. So I also need to send the target. So and then I can take, take will be equal to false initially, because if you see here it will be false, and here take will be changed. If I got a true, then it will be changed to true. So recur uh, index plus 1 and sum plus, I am taking the current index element, index comma nums comma target. So this is how we solve this problem by using recursion, but this will return something like a TLE, right? So recur, here is the function, and if index is equal to nums dot size, then we'll be returning, but before that return sum is equal to target. That means if sum is equal to target, then it will be returning true, if not it will return false. So but wait a second, here what can I optimize, right? Here I am having this 6 and then 6 here and then 1 and then 1 and then 1. That means I am doing the same state. I am going to the same state again and again. So in the top-down approach, I'll use something like a DB to store in a table all the computed values. So I will store the previous computed computed values. Now, how do I store this? How do I get this DP array or DP matrix? So I will use something like here I can go here something like n, right? N are the number of indices and the target is the maximum sum that I can get. So at index I can I get a sum of j. This is what dp of ij represent. dp of I comma j represents that can I achieve a sum of j by index 1. So do I have a subset of some j till index I? So here the values of dp will be something like n comma target plus 1. Target plus 1 is given because here I can get a sum of 0 every time. If you see the target sum is 0. So even if I take 0th index element, 1 index element, 2 or 3, I can still achieve 0. So everything will be true. So what I need to do here is n comma target plus 1. So this is the code for the recursion. So if I use a DP table, right, vector 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 int, right, dp of size n vector int, wait a second, dp of size n vector int of size target plus 1 comma 0, right? Now what instead I can do something like if it is true, that means when this recursion is true, so for that I'll give a dp in the recursion. So if I paste this over here, so I am having a vector int of dp. When will I return true? I'll return true if current sum is equal to target. So I will return true at that point. Now take is used for dp of current index and current sum is equal to take or not take, right? Now we'll be returning dp of index and current sum, but instead of take and not take I will use bool. So here bool take is equal to recursion of index plus 1 target, and I will pass this dp here. I'll pass this dp here. So if current sum is equal to target, then I'll return true there itself. If index is greater than or is greater than size and current sum is greater than target, then I will return false. So let me run this code to check whether it is giving a right answer or not. So pass by reference the dp index int n is equal to nums dot size. So right here I will be using something like if dp here instead of 0, let me use it as -1 if dp of index and current sum is already computed. If it is not equal to -1, then I will return dp of index and sorry dp of index and current sum. So if it is already computed, then there is no need to compute that again. So if I submit this, it will be taking much time, but I can even optimize this. Let us see how we can. Now Now let us see what changes can I make for this uh, for this DP solution. So this is the recursion solution. So if I change this with vector int of DP of size n, vector int again, vector int again of target plus 1 comma minus 1. So this means we are using a recursion table, sorry, a DP table to store the pre-computed values. So here before doing that, here let me pass this DP, and vector int of DP is also passed here, passed by reference. Now if the current DP of index and current sum is not equal to -1, that means it is already computed, then we will return DP of index and current sum. So here it will be DP, here it will be DP, and DP of index and current sum will be equal to take or not take. Let me run this. If I got any other target is not initialized, so int target, sorry, it is initialized here. So let me run this again. Right, so if I submit this, it is taking some much time, or but a less time than the recursion solution, but we can even optimize this. So how do we optimize this? We can use something like a recursion, sorry, a bottom up approach by using a 2D DP table. So before saying how does this DP table works or not, let me check that 1, 5, 11, and then 5. Now, what are the values, or something like what are the sum that I can get by index 1? But before that, let me tell you by index 1 here, right? Now, by index 1, I can get a sum of 1, and I can get a sum of 5, and I can get a sum of 6, right? But from these three, I need to know whether I can get a sum of 1, sum of 2, sum of 3, sum of 4, sum of 5, 6, and at last I need to get a subset of only sum of 11. That's what my target is. So I will write 7, 8, 9, 10, and then 11. Now let us see. Let me compute that. Here also I have used the same target plus 1. That means n is the indices, and target plus 1 is the number of columns, and n is the number of rows. Here also I am using the same DP table, but 0 is achievable. So the sum 0 can be achievable. So I will write 0, 1, 2, 3, 4. I am using 4 indices because I will go from nums of I minus 1 every time. Now true, and then true, and then true. Now I have the sum of 1. What does this mean? At this point, I will tell in the DP, I will store in the DP whether sum of 1 is achievable by taking no elements. No elements. I am taking no elements, whether is it achievable or not. But here I will initialize everything as false, but only this column will be initialized to true. Now let us see, this will be skipped. That means we are not checking, we are not taking any element. So we'll be skipping this. Now we'll be taking one index. That means I am taking 1. So if I take 1, what are the values that I can get, or what are the differences that I can make? Let me say that here I have 1. Can I take 1 minus 1? Why 1 minus 1? Here the target is 11. When the target is 11, I need to know whether can I achieve target. So if I say you this 11, now what can I add? Something like, imagine, just imagine I have a true here. Just imagine I have a true here. Now I am not taking this indices, I am not considering all this, I am just considering 11, and the current element, the current number is 1. Don't consider, I am telling you again, don't consider these indices for a while. Now I have 11 as the sum. What does this mean? Can I achieve 11 as the sum at this index, no matter what the index is? Can I achieve this sum of 11 by what can I add maximum? What I can add maximum? I can add at most the current number num. At most the current number num. Num is 1. So I will go current number, current sum minus num. Current sum minus num will give me true. So what does this mean? That means I am having a 10, a 10 as the sum, and I can achieve true. I can achieve 10 so that I have true there. So if I add the current number, then I can achieve 11 as the sum. This is what the whole DP table tells us. If I add 1 to 10, then I can achieve number 11. That's what this DP table tells us. So I'll put a true here. But before that, let us not confuse. So what I am checking? I will be checking from now. What I am doing here, our target is 11. I'll be iterating from I is equal to 0 to n, and for every I, number will be nums of I minus 1. So number will be nums of I minus 1. Let me let you not forget that I will be 1 to target. Right now, if j is lesser than nums of I minus 1, then do I have any choice? Then I cannot add this, or I cannot add that number to the current number and get this sum. So it will be dp of I, and j will be dp of I minus 1 and j. That's it. Else, that means the current number, that means the number which I am iterating, is greater than or is equal to nums of I minus 1. What does this mean? If I am having something like a number of 11, and the sum of 11, I am pointing here. Now if I am having something like here, if I have 3, so 3 is the number. So if I am at here, then I can consider this as the sum. So else else dp of I j will be dp of I minus 1 and j, or dp of I minus 1 j minus nums of I minus 1. So this is how you solve this problem, by checking the dp, and at the last, after this, we'll be returning dp of n and target. So this is how this algorithm works. So this is a 2D DP. So if you look at the code, here is submission. If you look at this code, here I have took dp of I minus 1 and j is iterating from less than or is equal to target. I is equal to 1, I is less than or is equal to n. Here dp of ij is equal to dp of I minus 1 and j. So every time I get to current sum, I'll be looking back to the previous number. That means difference of the number. So if I consider only 1D DP approach, I will be not using this 2D DP. Instead, I'll use a 1D DP which stores the current number, the current value, whether it is true or not. So we are having target plus 1. dp of 0 is true. We can achieve dp 0 as the sum without taking any elements. So j is equal to target and j is greater than or is equal to number. So here it is like reversed, right? So here we are going from j is less than nums I minus 1. Here also I am going till j is greater than or is equal to num. That means I am going in reverse order. J is starting at the current sum and current target and going in the reverse order. So dp of j or dp of j minus num. At the last, we'll be returning dp of target. So this is how you solve this problem. If you like this video, do share it to your friends and do subscribe to my channel. Thank you.